The modern aerospace domain is an arena where high-stakes strategy is tested by the unforgiving constants of physics, and where geopolitical ambition is relentlessly fractured by fiscal gravity. Defense acquisition exists at the nexus of complexity, defined not by the grandeur of a project's vision, but by the meticulous, relentless management of microscopic, essential details. The specified stress tolerance of a single titanium fastener, the perfect phase alignment in a radar array, or the flawless, uncorrupted integrity of a line of guidance code. For the Republic of Korea, the massive, multi-billion-dollar investment into the KAI KF-21 Boramae is the physical manifestation of this brutal, high-stakes struggle for strategic technological autonomy. The Boramae program, known initially by its developmental placeholder, the Korean Fighter Experimental, KFX, was born from an urgent strategic necessity: the mandated replacement of the Republic of Korea Air Force's ROKAF rapidly aging front line. For decades, the nation relied heavily on a mixed fleet that included the venerable, but now hopelessly obsolete, McDonnell Douglas F-4DE Phantom II heavy fighters, relics of 1960s design, alongside the numerous Northrop F-5E F Tiger II light fighters. These aircraft, having long surpassed their planned airframe life, represented a maintenance and operational burden that demanded a generational leap in indigenous capability and sustainment, minimizing reliance on the fluctuating political winds and export controls of foreign suppliers. The initial KFX project harbored the grand ambition of creating a pure fifth-generation stealth platform, directly mirroring the very low observable VLO capabilities of the world's elite combat aircraft. However, the sheer impossibility of mastering every requisite technology, from advanced stealth coatings to the complex digital architecture, domestically and within a financially acceptable and politically viable time frame, soon forced a strategic reckoning. Led by Korea Aerospace Industries, KAI, and the Agency for Defense Development, ADD, the program executed a highly pragmatic pivot, adjusting the requirements to focus on a 4.5 generation fighter standard featuring controlled, limited stealth capabilities. This strategic course correction minimized the initial technical risk and radically shortened the time required to field an operational aircraft. In an industry globally defined by crippling developmental delays and astronomical cost overruns, where the complex process often necessitates a painful, decade-long ritual dance of bureaucratic renegotiations, the Boramae program stands out for its unorthodox success. It has remarkably adhered to its original timeline and budget, an accomplishment that has secured its reputation. The first prototype successfully flew in July 2022, serial production commenced in July 2024, and the ROKAF expects to introduce the platform operationally in 2026. The strategic calculus underpinning this approach is clear. South Korea already operates the VLO capability provided by the F-35 Lightning II. The KF-21 is not intended to compete with the F-35 in the deep penetration role. Instead, the Boramae is engineered to be a high-volume, cost-effective, high-performance workhorse designed to function as a highly capable missile truck and sensor multiplier in a strategic high-low force mix. This block-I approach prioritizes reliable, high-performing utility over absolute stealth, establishing a mature airframe that can reliably anchor future escalations of technology. The initial plan targets the delivery of 40 Block Y units starting in 2026, with a final goal of deploying 120 Block II units by 2032. This phased evolutionary path ensures the KF-21 will not only replace the F-4 Phantom II and F-5 Tiger II, but will eventually relieve operational pressure on the current fleet of F-16 Fighting Falcon and F-15K Slam Eagle aircraft. This initial success in speed and execution sets the stage for a much deeper technical examination of the aircraft itself. Yet every tactical advantage provided by the Boramae's sophisticated design must first rely on the brute force provided by its propulsion system. The architectural design of the KF-21 Boramae is that of a heavy fighter, reflecting the necessity for long-range operations and a substantial combat load. The aircraft measures 16.9 meters in fuselage length and 11.2 meters in wingspan. This sizable airframe is specifically engineered to support a substantial maximum takeoff weight (MTOW) of 25,600 kg, facilitating the necessary internal volume for both advanced avionics and a generous internal fuel carriage of 6,000 kg. The pivotal architectural decision that fundamentally defines the Boramae is the selection of a twin-engine layout, marking a key divergence from single-engine contemporaries like the F-35 Lightning II. This choice prioritizes power, thrust redundancy, and reliability, factors critical for extended maritime operations and deep strike missions. The aircraft is powered by two proven General Electric F-414 GE 400K turbofan engines. This engine is a proven international workhorse, powering platforms from the U.S. Navy's Boeing F/A-18 Super Hornet to the Saab Gripen EF. These twin engines generate a combined thrust of 44,000 pounds-force, enabling the Boramae to achieve a maximum airspeed of Mach 1.81. Beyond raw speed, the airframe's aerodynamic efficiency, combined with its substantial fuel capacity, translates into impressive operational endurance. The Boramae boasts a ferry range of 2,900 kilometers and a combat radius of 1,000 kilometers. This operational reach is strategically significant, offering approximately a 50% greater range than the ROCAF's existing F-16 Fighting Falcon fleet and promising a 34% longer airframe life. This extended operational window is vital for maneuvering within the demanding airspace requirements of the Korean Peninsula. However, the use of the F-414 GE 400K engine, while ensuring reliability and accelerating development, exposes a critical, albeit calculated, performance compromise: the supercruise conundrum. The F-414 is a high-performance engine, but it is not natively optimized for sustained supersonic flight without the use of fuel-hungry afterburners. The current reliance on afterburner power to achieve Mach 1.81 means high-speed performance is achieved at the inevitable cost of accelerated fuel burn rates and reduced tactical endurance. This technical shortfall provides the precise justification for the massive parallel investment being made by the Iraqi government. South Korea has committed 86 billion won toward launching the independent development of an indigenous advanced jet engine, specifically to eliminate this foreign dependency and to push future KF-21 blocks into true supercruise capability. The decision to deploy the F-414 should therefore be viewed not as a limitation, but as a deliberate and highly effective risk mitigation strategy. By integrating a mature, off-the-shelf engine, KAI successfully eliminated the highest-risk technical element from the initial blocks, ensuring the simultaneous development of the airframe and the crucial indigenous avionics remained strictly on schedule. The Indigenous engine project is thus a long-term strategic endeavor aimed at eliminating foreign leverage over a critical system and securing genuine fifth-generation performance characteristics post-2030. For the immediate future, the KF-21 operates securely within the high-end 4.5 generation physics envelope. But this reliance on external power necessitates an understanding of the aircraft's current operational visibility, a visibility that is deliberately managed through its design geometry. In the complex lexicon of aerial combat, the KAI KF-21 Boramae occupies the crucial yet often misunderstood category of a reduced observable RO platform. This classification is fundamental as it explicitly positions the aircraft above standard fourth-generation fighters but below the technical threshold for true stealth, or low observable LO, which is typically defined by an RCS below 0.01 square meters. The Boramae is designed to mitigate radar detection range, enhancing survivability against existing air defense systems rather than challenging next-generation sensors in a head-on VLO engagement. KAI's designers were meticulous in shaping the airframe to incorporate key radar reduction features. These efforts include the clean, angled fuselage structure, engineered to deflect incoming radar energy away from the source, and the essential installation of S-duct air intakes. S-ducts are a critical aerodynamic mechanism that prevents line-of-sight exposure to the highly reflective engine compressor blades, which are often the largest single contributor to an aircraft's radar signature. Furthermore, external sensor protrusions have been largely eliminated, replaced by flush-mounted antennas, lending the aircraft its distinct, sleek cosmetic resemblance to the F-35 Lightning II. However, the adherence to the 4.5 generation standard necessitated fundamental, visibility-increasing compromises, particularly for the operational Block 1 and Block 2 variants. The aircraft was primarily engineered for maximum operational flexibility and raw combat payload, relying on 10 external hardpoints for its armament. These hardpoints support a vast external payload capacity of 7,700 kg, allowing it to carry heavy munitions such as the AIM-120 ARMAM air-to-air missile, the AGM-65 Maverick, the Taurus KEPD-350 cruise missile, and various guided bombs. The unavoidable aerodynamic and electromagnetic consequence of carrying such external reflective metallic objects beneath the wings is the creation of inevitable radar spikes, transforming the KF-21 from a partially stealthy design back into a high-performance but inherently detectable fighter. Further technical assessment reveals specific engineering trade-offs where certain high-effort RCS treatments were deferred in favor of manufacturability and cost control. Highly complex elements, such as sawtooth treatments along major access panels, a signature feature of VLO designs used to prevent radar energy from entering the internal structure, and fully integrated conformal antennas, were not implemented in the baseline airframe. These omissions underscore the engineering reality that low observability is an exponentially difficult and costly endeavor. KAI chose to pragmatically manage the detectability curve, sacrificing deep penetration stealth for a maximum operational payload and cost efficiency required of a primary national defense asset. The strategy involves utilizing Block Y as a heavy, survivable weapon truck, a choice that ensures robust air superiority missions today while deferring the costly, complex leap to true stealth until the necessary technologies and budgetary windows align in the future Block 3 iteration. This strategic staging ensured the airframe could fly on time, but the true measure of its combat worth lies not in its shape, but in the electronic warfare domain it inhabits. If the KF-21 Boramae's airframe represents a series of carefully managed compromises, its core avionics suite stands as a powerful declaration of technological triumph and national independence. The paramount achievement in South Korea's push for technological sovereignty is the successful domestic development and fielding of the Active Electronically Scanned Array, AESA, radar by Hanwha Systems. AESA technology, relying on complex high-power semiconductor transmit-chuck-receive modules, TR modules, represents a formidable technological barrier that only a small elite group of advanced countries, including the US, UK, France, Sweden, and Israel, possess the necessary source technology for. The integration of this indigenous radar system, with the first mass-produced unit rolled out in 2025, is the strategic centerpiece of the KF-21. This success was built on vertical integration and inherited expertise. The KF-21's multifunction radar, MFR, directly draws its technological lineage from South Korea's M-SAM Cheonggung system, medium-range, surface-to-air missile defense radar. This shared heritage provides the KF-21 with a highly specialized and vital strategic capability. Beyond standard air and surface target detection, the radar is explicitly engineered to detect and track high-speed ballistic missile targets, including those maneuvering during the critical re-entry phase. This capability instantly transforms the KF-21 from merely an advanced fighter into a multi-purpose tactical node, deeply integrated into the National Ballistic Missile Defense Architecture, a powerful geopolitical asset that distinguishes it from many contemporary export fighters. The AESA radar is seamlessly integrated into a comprehensive digital sensor suite that includes an infrared search and track (IRST) system and a sophisticated, domestically developed electronic warfare (EW) suite. The aircraft's digital backbone facilitates advanced digital beamforming and aims for real-time data processing crucial for managing multiple, simultaneous missions, from zone search and queuing to guided missile coupling. This mastery over essential hardware systems has profoundly solidified the domestic defense industrial base, allowing the KF-21 Block 1 program to achieve a local component production rate reportedly exceeding 65%. This vast network, involving over 600 domestic firms, ensures that technology transfer, long-term maintenance, and future modernization remain firmly under sovereign national control. While the hardware, the AESA radar, the IRST, and the EW components, is indigenous and robust, meeting world-class standards, the ultimate technical hurdle in this domain remains the challenge of sensor fusion. True combat effectiveness in a modern environment is not determined solely by superior hardware, but by proprietary software's ability to instantly and seamlessly combine multispectral data, radar, thermal signatures, passive electronic intelligence into a single, intuitive tactical display for the pilot. This requires decades of iterative development in cognitive electronic warfare algorithms and high-speed processing capabilities. The maturity of the KF-21's sensor fusion software, its capacity to integrate the new platform with older fleets and with forthcoming drone swarms, represents the final and most demanding mini-mystery that will ultimately determine its combat equivalence against established global contenders like the Eurofighter Typhoon or the Dassault Rafale. This mastery of technology is deeply interconnected with the volatile realm of global defense partnership, which has provided one of the program's biggest headaches. For international customers, and indeed for the ROCAF's long-term sustainability, one of the KF-21's most compelling strategic advantages is not its raw thrust or its stealth profile, but its affordability. A defense research official calculated that the Boramae is projected to cost approximately half as much per flight hour to operate compared to the Lockheed Martin F-35 Lightning II. Given that U.S. F-35A operating costs are currently estimated at around $36,000 per flight hour, this massive financial differential renders the Boramae an economically viable, high-performance workhorse. This financial calculus ensures high utilization rates, crucial for maintaining a ready fleet without the prohibitive maintenance costs associated with true VLO platforms. The KF-21 was politically launched in 2015 as a joint development project, an attempt to secure external financing and signal export appeal early in the process. Indonesia was the chosen partner, agreeing to shoulder approximately 20% of the project's total cost, originally valued at 1.7 trillion won. In exchange for this significant commitment, Jakarta was promised technical support, the transfer of key technology, and 48 units of the Indonesian variant, the IFX, to be locally produced. The reality, however, proved to be an object lesson in the volatility of international defense partnerships. The Indonesian commitment was repeatedly plagued by significant payment delays, seriously threatening the fiscal schedule of the project. By 2024, Jakarta successfully negotiated a massive, almost two-thirds reduction in its financial obligation, cutting its total share to a mere 7.5%, and reducing its final contribution to 600 billion won, in exchange for a significantly curtailed scope of technology transfer. The finalization of these revised terms was further delayed following an incident that escalated the financial dispute into a diplomatic crisis. Indonesian engineers stationed at KAI were allegedly caught attempting to exfiltrate critical technology and proprietary data in 2024. This incident, compounded by reports of renewed diplomatic ties between Jakarta and Pyongyang, dramatically highlighted the immense geopolitical risk associated with technology sharing and validated the most conservative voices in Seoul who advocated for absolute technological isolation. The strategic implication of this crisis is notable. Despite losing 2/3 of the promised Indonesian funding and suffering a major security breach, the KF-21 program remained rigidly on schedule, beginning serial production in 2024 and adhering to its 2026 introduction date. This resilience confirms that the project's technical and fiscal viability was always underwritten by the unwavering commitment of the ROK government, rendering the external financing politically important but technically superfluous to the core program. The eventual failure of the IFX partnership, though financially inconvenient, ironically allowed Seoul to reassert total control over its sensitive intellectual property, thereby strengthening the competitive integrity of future wholly Korean export sales. This protection of the core design is non-negotiable as the program now faces the next great technical leap, the transition to a true fifth-generation configuration. The phased block strategy is the Boramae's defining industrial characteristic, an engineered, staged escalation of capability designed to manage the exponential rise in technological difficulty and cost. The platform is not a static design. It is a continuously evolving aerospace architecture. The current operational phase is centered on Block 1, 2026, defined as an air superiority fighter, replacing the legacy fleets with indigenous avionics and relying exclusively on external air-to-air missile carriage. This phase focuses on achieving airframe maturity and pilot training. The subsequent phase, Block 2, by 2032, shifts the platform into a full multi-role combat aircraft, focusing on the integration of expanded air-to-ground capabilities and utilizing the full spectrum of external precision strike weapons available to the ROCAF. The ultimate and most ambitious goal is the conceptual KF-21EX, Block 3, which aims to push the platform across the final barrier and into the true fifth-generation stealth category. Achieving this requires navigating the most difficult architectural challenge in modern aerospace: the radical transition from external carriage, which characterizes the 4.5 generation approach, to internal weapons bays. For Block 3, KAI envisions internal bays capable of housing 4 advanced air-to-air missiles, such as the MBDA Meteor, alongside precision-guided bombs. Designing this complex internal cavity is not merely a matter of finding space within the fuselage. It requires intricate structural engineering to ensure the opening and closing of the bay doors does not momentarily compromise the airframe's structural integrity during high-G maneuvers or significantly negate the stealth signature. This retrofit effort is an immense engineering task, demanding what analysts have called a radical structural redesign of a platform that was not initially optimized for such features, potentially risking unexpected compromises in internal fuel capacity or overall weight. Alongside the internal bays, the Block 3 vision includes upgrading the airframe with full-fledged, low observability features. These planned enhancements include a fully reprofiled canopy to minimize radar glint, a lower RCS radome, and more extensive application of radar absorbent structures, RAS, and specialized materials, supported by a separate 630 billion won investment. Furthermore, the bulky external targeting and reconnaissance pods, which currently spike the RCS profile, will be eliminated, replaced by a sophisticated internal electro-optical targeting system, EOTS. Crucially, the entire transition to the heavier, stealthified Block 3 airframe relies absolutely on the success of the Indigenous Advanced Jet Engine program. While the F-414 provided the necessary, reliable start, only a domestically developed engine can eliminate the final foreign dependency and secure the necessary thrust-to-weight ratio to push the KF-21EX into sustained supercruise performance in the early 2030s. This convergence of indigenous power and indigenous stealth geometry is the final high-stakes technological marathon that will determine the Boramae's standing among the global elite. The recognition that the KF-21, even in its ultimate Block 3 configuration, may not achieve the absolute very low observable VLO profile of the F-35 Lightning II has driven KAI toward a highly strategic focus on force multiplication. The future operational philosophy centers on manned-unmanned teaming, MUM-T, positioning the KF-21 as the sophisticated command node for networked swarms of uncrewed assets. The core of this strategy is the development of the Low Observable Unmanned Wingman System, LOWUS, stealth combat drone. This drone is designed with its own reduced radar cross-section features and incorporates radar-absorbent materials, positioning it to function as a disposable shield, a forward reconnaissance platform, and a powerful electronic warfare extension. The expected operational structure involves a specialized two-seat variant of the KF-21, which is anticipated to play a pivotal role in controlling these drone swarms, allowing the manned fighter to remain at a safer, standoff distance, while the LOWUS drones extend the tactical profile deep into highly contested airspace. The development of the LOWUS, which resembles counterparts like the U.S. XQ-58A Valkyrie, began in 2021 and aligns perfectly with the KF-21's transition into a highly connected platform, ensuring the ROCAF's future readiness against sophisticated denial zones. In the high-stakes global marketplace, the KF-21 Boramae is positioned perfectly within the high-end export sweet spot. It offers a capability leap far superior to upgraded fourth-generation fighters, yet is demonstrably more cost-effective than the F-35. Furthermore, as a platform striving for over 65% domestic content, it promises potential export customers fewer of the political export restrictions that are frequently attached to U.S. VLO systems. This combination of performance and independence is already attracting international attention, notably from the United Arab Emirates, UAE, which has expressed interest and conducted site visits to KAI's production facilities. However, the KF-21 must contend with a brutally competitive global landscape. KAI faces established rivals like the equally high-performance F-414-powered Sabi Gripen EF, which benefits from deep industrial partnerships. More aggressively, the Boramae competes with the rising power of the highly cost-effective Sino-Pakistani JF-17 Block 3. The JF-17 Block 3, now exported to nations like Azerbaijan, offers sophisticated capabilities, including AESA radar and modern munitions, appealing strongly to markets seeking readily available alternatives to Western suppliers with minimal political conditionality. The KF-21's ultimate market success will depend on its ability to offer a compelling balance of near fifth-generation capability and stable, politically clean supply chains, something the Indonesian partnership crisis almost derailed. The KAI KF-21 Boramae is demonstrably more than a routine fleet modernization program. It is the $8 billion foundation of a sovereign South Korean defense industrial base. The program represents a national commitment to strategic autonomy, moving beyond simple licensed production to achieve self-reliance in the most challenging areas of military aerospace technology. The program's adherence to its highly ambitious schedule, the proven mastery of its indigenous AESA radar and sensor suite, and its determined ambition to eliminate the final foreign dependency through the development of a domestic turbofan engine, are all components of a cohesive, long-term national strategy. The phased, evolutionary approach, transitioning the platform from a reliable 4.5 generation workhorse in Block 1 to a multi-role fighter in Block 2, and ultimately targeting a full 5th generation stealth configuration in Block 3 EX, is a model for managing high-cost, high-risk development programs. The greatest technical challenge remains the integration of internal weapons bays into the Block 3 airframe, a complex structural modification that must not compromise the aircraft's stealth or its superb aerodynamics. Simultaneously, the program must secure its intellectual property against further technology transfer incidents, particularly as it seeks to expand its footprint in the increasingly competitive global export market. The KF-21 Boramae stands as South Korea's powerful, unambiguous statement. Its future in the air will be secured, manufactured, and controlled entirely at home. Having successfully navigated the perilous waters of early development and production, the Boramae now embarks on the critical developmental phase, where its fate will be determined by whether its industrial ambition can successfully overcome the demanding, unforgiving physics of 5th-generation technology. The aerospace world waits to see if the pragmatism of the current platform can truly metamorphose into the pure stealth promise of the future.